It's a lot more expensive than you think having poor quality code. There are lots of hidden impacts. You've got the obvious stuff is the cost of fixing bugs, right? Because you've got poor quality and people find issues. And that cost gets exponentially more expensive the closer to production you get, right? More expensive to fix it with the customers. But you've also got the cost of customer support. That's the obvious stuff. The things that people generally don't think of is things like brand reputation, right? What is the impact on poor quality on brand reputation? Not just poor quality in your product, but poor quality in the way you do things. The most recent one is CrowdStrike, right? They had poor engineering practices that resulted in a massive global impact when something went wrong. And all they did was what lots of companies do, which is push something to production and didn't really think about controlling the blast radius or any of the other modern engineering practices that they might have. So you've got loss to your brand. You've got productivity of your team, right? Everybody's got to run around trying to figure out what the problem is because it's too difficult to figure it out, then you're going to have a massive loss of productivity. Not just productivity. There's lots of engineering practices that people use that reduce quality, but they don't think it reduces quality. One of those is branching, right? Having a really large branching strategy. I worked with a company recently that had 96 teams, and they had 96 branches, 96 long-running branches, one for each team. And then each team created their own branches of that. And the cost in lost productivity to maintain that, to ensure that you have working product, is just enormous. And add to that, if you're maintaining multiple versions of your product, right? This is a massive cost. You in general, you should not be maintaining multiple versions of your product. You should not be supporting multiple versions of your product. You should be supporting the latest version of your product and not anything else. In general, off the top of my head, I can think of circumstances where I might have 2 versions of my product, or maybe 3 absolute tops. But if you have more than that, perhaps you have a version of your product per customer. That's a very common one. That's a massive cost, not just to support and maintenance, but in lost productivity. If I'm a developer and I fixed a problem, I fix a bug, right? Could just be a bug. Let's take that as an example. I fix a bug in the main version of our product, the latest version of our product, but we realize that it's in lots of customers' versions. Maybe there's 10 customer versions have this bug. Can I fix it the same in all of those versions? Probably not, right? Because they diverge over time. And perhaps things that I used to fix the product as part of the fix in the main version aren't there in older versions. Or it's slightly different, or it's not quite the same version, or all kinds of. That increases the cognitive load on the engineers. It increases the likelihood of something going wrong because you're increasing that cognitive load. And because you have to backport all of those fixes across all of those different versions, what's the cost in missed opportunities? Because your team's having to mess around with lots of work that is avoidable. I'm going to put that in there. These are all avoidable losses in productivity. What are the missed opportunities for your business? What features are you not able to ship because it's harder for you to add features? A great, fantastic, my favorite example is some data from the Azure DevOps team. The Azure DevOps team had a very long tail on figuring out whether they'd been successful in building the product, right? The engineers had been successful in the code that they write and having the test and validation, all of those things done. And it was taking 48 to 72 hours to figure that out. They invested a bunch of time and energy in paying back poor choices they'd made in the past. Some of them deliberate, that's okay, but poor choices they'd made in the past, and things they didn't realize were poor choices in the past that they now realize were poor choices. Paying that back, it took them nearly 4 years of investment in that story to fully pay it back, right? You know, just like if you take out a loan, you pay it back over a longer period of time, a little piece at a time. So they were paying it back as they had time. They were prioritizing it. So it was important to them. So they were spending time on it, but they're also doing other things. So it's getting done over time. So it took them 4 years to pay it back. But that plus fixing that problem, refactoring that problem, re-architecting that part of the problem so that they went from 72 hours, that was the longest, 72 hours to find out whether you'd broken stuff, to 3.5 minutes, right? So that's a massive shift. So shifting from long-running system tests to small, discrete unit tests as their measure of validation massively impacted their productivity. They went from 25-ish features to production each year with 650 people to over 800 features to production with the same 600 people. Not quite the same, right? Because it's 4 years' time, but more or less the same 600 people. And even in the first year, when they had a really big focus on paying that back, although there was a long tail, right? A really big focus on paying it back. They spent most of their time in the first year focusing on fixing a lot of these types of architectural problems, of dealing with that. They weren't focused on features. And they still managed to go from 24 features to production to like 60 something features to production. Almost 3 times the number of features were delivered to production at the end of the first year. And they weren't even focused on delivering features. They were focused on building up engineering excellence, fixing those older problems that had crept in over time. You know, it was like 15 years working on this product. And it had this massive, massive boost to not just productivity, right? The productivity of the team, but brand reputation went up because you're delivering more features, more experiments, more things that your customers need. You're missing less opportunities, and you're having less security breaches. Because if we're iterating much more quickly, which is what you're trying to do, is reduce those feedback loops, you can't leave security to the end. One of the main reasons that companies get large scale, high cost security breaches is that they leave security is an afterthought. It's not baked into the process. And if security is an afterthought, you find a problem in the way you've architected your product. It's a lot of work to go back and fix that. So most people and teams don't, because it's maybe hundreds, thousands of hours to go fix it. Or we could get out the sticky tape and super glue and stick over the top and create something over the top that prevents the hackers getting into that flaw. But hackers spend copious amounts of time figuring out how to peel back the edges of those sticky things and get underneath and get it access to the system. So by paying back this technical debt of increasing the level of quality in your product, you have all kinds of exponential benefits to your ability to deliver product to your customer, the happiness of your customer, and you're able to not just reduce costs. Technical debt is not just a cost. It's what would you call it? Missed opportunities, right? What money are you leaving on the table because you haven't had the ability to go tackle those opportunities? You haven't had the ability to try those things. This is fundamentally why having high quality, usable working product on a regular cadence is a superpower for your teams and for your organization in your ability to deliver value.